Welcome back. We're doing homework number 7 at thermodynamics 2 at thermodynamics 2 at South Coast School of Mines and Technology. This is problem number 3. Homework number 7 is associated with flash. So problem number 3 is actually the third part of a 3-part problem. Okay, so the first part, we had this VLE diagram, we tracked the path. The second part, which is seen here, which I've left, is what are the compositions at all those different points. The third part is now we have this information, now we can gain a glean into what's going on in terms of mass balance. Okay, so it says assuming the initial feed rate is 100 kilomole per hour, what is the flow rate coming out of the throttling valve? Like, what the? Okay, well, I got a lot to go. I got a lot to do here. Okay, what's the first thing I do after I know it's a mass balance problem in a mass balance problem? I draw my picture. Okay, so I've got to read through the problem to figure out what's going on. So I have it. So it comes in and it's going through a compressor. So let's see here. So this is a compressor. Okay. Okay. The pressure is raised, blah, 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 and the stream exits, okay? I add, so I have some sort of mixer here, okay? And I'm adding a pure stream of component 2. So this is pure 2 is coming into that guy, okay? The pressure drops, okay? And so, after it comes out, it has a new pressure, okay? The mixture is fed into a flash tank, and maybe I want to just, to indicate that pressure drop, and maybe I do kind of like a little, like a little turbine here or something. Okay, so pressure drops. That will indicate our pressure dropping. All right. Let's see here. The mixture is fed into a flash tank. So this goes into a flash tank. Where it's separating the liquid. Okay. The liquid is sent to a throttling valve, and this is sent to another compressor. Okay. So again, there's my picture. Okay. So, and then I have all these things that are going on that correspond to this. So let's just kind of figure out what's going on here. So I have a feed, I have kind of, stream, this is stream B, this is pure 2, so we'll just call that stream P, okay. There's, what's coming in is going to be coming out just at a different composition, so we'll call that, let's see here, we'll call this stream D, and this one's stream C, okay. Obviously this is E1, and this is F1, this is E2, F2, okay. All right. Assuming the initial feed, so NF is equal to 100 kilomoles per hour, okay. What is the flow rate coming out of the throttling valve? So I'm trying to find out what's, basically NF2, okay, so what's NF2 equal to? I have no idea. Okay, and so there's there's a couple ways I need to, there's a couple things that need to be done in this one. This is a bit more complex than what you might see on a homework assignment, but all the information is there. It's actually well overstated. Okay, the main thing I first need to figure out. Because, okay, I know NF, so that's the exact same as B, and, okay, and C and D are exactly equal to each other, because that hasn't changed. There's something going on here, but I don't know how much P is coming in. So I first should probably figure out how much P is coming in, so I know, because no matter how I draw my boundaries, I'm still going to not know P, okay? Because let's say I draw my boundary here, okay, because that's the other thing, I need to draw my boundary, right? So if I draw my boundary there, well, I don't know what C is because I don't know what P is, okay, and so on and so forth. So let's draw a mass balance. Let's draw our boundary first around our little mixer, so to speak. Let's figure out what's going into the mixer, because I know what B is, and I know some other things about, I know all the compositions associated with B and C, so I should be able to figure out how much C is coming in. Because what's the composition of P? Z equals 0. Z1 equals 0 because it's pure component 2. Okay. So let's do that. Okay. And I know I'm running out of room. We'll just try and squeeze it in here. We'll kind of shrink down a flash tank. Yeah, how about we do that? So we shrunk down our picture. Okay, so let's do our mass balance around here. So first let's do an overall. Okay, so we've got NB, which we've already said that NB equals NF. Okay, so really we can say this is NF. Okay, so NF, but let's be proper about it. So NB plus NP is going to equal NC. Okay, what comes in is equal to what comes out. Of course, we've already said that NB is equal to NF. Okay, so we've got that one, so we know how much that one is, because we know how much this one is. Okay. We don't know how much this one is. We don't know NC. Okay, we need a second mass balance. Okay, let's do it on component 1. And so what we want to do, now we're going to assume everything is associated with component 1, so we don't have to have a subscript associated with component 1. Let's just say Z or Y or whatever, and we'll just say of what point. Okay, so what we want, we want the Z of B. So Z of B times N of B plus how much component 1 is there in the pure stream? 0. So there's not anything coming in. The only thing that 1 has is whatever comes into B. So whatever's in C is what came into B. So the Z of C is equal to, so this is what, this is the same. Okay. Now, do I have a Z of B? I do. It's 90%. Do I know NB? Yeah, we said it was the N feet, which is 100. Okay. Do I know NC? That's the one I'm trying to find. Do I know ZC? I do. I know it was 80%. So from number 1, I had to figure that out from number 1 anyways. Okay. So from number 1, I know that this is 80%. Okay, so I can solve for NC. So NC is just equal to ZB NB over ZC, which is equal to 0.9 over 0.8 times 100. What is that? Oh, off the top of my head. Yikes. Let's see here. Gosh, I'm brain fart. Kind of like, let's just say it's approximately 110. Eyeballing it, that sounds about right. Maybe, no, I think it'd be 112.5. That makes sense. That makes sense. Because it's it's 1/8. Yeah, 1/8 is 1.125. So, okay, 112.5. Okay. So that's NC. Well, NP is equal to NC minus NB. Okay, well 112 minus 100, so NP has to equal 12.5. Okay, so I know how much is coming in now. There's 12.5 coming in. Okay, now I can figure out what's going on here. But, in a sense, I didn't need to even do that, because once I had this 112, I knew it was coming into C, and I know what comes in the C is equal to what comes in the D. Should I show that? Yeah, I should. I'm not going to, but you should. You should say, okay, I did the mass balance. What comes in the C comes in the D. Okay. Just to show it, to show that you know that. Okay. So, I mean, if this was a mass balance class, I would be a little bit more rigorous about it. Okay, but it's not, so I'm not going to be as picky. You should know better, more than anything. Okay, so I need to figure out, okay, and I know what comes into the throttling valve is what comes out of the throttling valve. So I just need to know what's coming out of the liquid of the flash tank. Now, I could do this kind of mass balance system of equation nonsense, but you know what? I already know what's coming out of that bottom. So just take a second. How do I already know? I mean, like, how do I really, I mean, it's really quick. How do I know how much is coming out of the bottom? Okay. I know that in this tank, it's 50% vapor, which means it's 50% liquid. I know that what came in is 50% liquid. And if all the liquid's drained, well, that means 50% of what comes in comes out this bottom. And so I can say with complete confidence that NF2 is equal to the liquid fraction of ND. Or rather, let's be proper about this. NE2. Okay, so NE2. So, but again, NF, which this equals NF2, and this equals LF times NC. Well, I know NC is 112.5. 50% of that, what is that? 67.25? No, that's not right. 66.25. Yeah, that's, or, no, 56.25. Yeah, 56.25. So what's coming out of, what is the overall composition of what's coming out of the throttling valve? 56.25. Now, I might have asked, I don't know, did I? No, I did not. Okay. I might have asked, how much component 1 is coming out of the throttling valve? Okay, and that's a different story. So I didn't ask that, but let's ask that question really quick. How much component 1 is coming out? Is there 56.25 of component 1 coming out? No, that's the overall. So how do I know how much component 1 is? I look at the Z, okay? And for stream, you know, so again, we're looking at the liquid, which is F1, okay? Oh, these are 1s, not 2s. So 1, okay. Well, it says down here that E1 is 0.85. So whatever 0.85 times that, that's how much is actually coming out, okay? You know, whatever that is, 0.85 times that. So the bottom line of this one is, you know, you got to draw your picture, you got to draw your boundaries, and then you just kind of have to focus on, you know, you have so much information, utilize it. You know, so you can really minimize how many mass balances you really need to do. And the other thing is when it comes to flashes, because I know the vapor fraction, if I know how much comes into a flash, I know how much comes out of the flash. It's that easy. Now, if I don't know what's coming in because of some, you know, maybe there's some recycle stream or something that mucks up the works, okay, that makes it difficult. But if there is one thing coming in, I can just look at the vapor fraction of that one thing coming in and figure out how much is coming out.